Okay, in this video, we're going to be doing Calc BC Problem Set number 6. The problems and a playlist are in the description below. Let's take a look. Graph of f shown above with domain -1 to 5. Let g of x be the function defined by g of x is 2 plus the integral from 0 to x f of t dt. All right, we want to find the x coordinates of the points of inflection of g of x, and we want to justify. So we got to start off by connecting g to g prime. So I have to find g prime. Second fundamental theorem, g prime is f of x. So take the upper bound, plug it in, times the derivative of the upper bound. Technically, it's f of x times 1, but we don't really write times 1. All right, my favorite way of finding points of inflection from the graph of the derivative is to look for relative extrema. So I look at this, and I can see here and here. So I'm going to say that g of x has points of inflection, or POI. That's a valid way to abbreviate that, at x equals 2 and x equals 4. I have to give a reason. So my reason is going to be because g prime has relative extrema at those x coordinates. That's really all you need for this answer. So just make sure you can fly through problems like that, right? So you can kind of bank that time and use it on more interesting questions. Let's take a look at the next one. Same setup. We want to find the absolute maximum of g of x on the interval from 0 to 5. So not from -1 to 5, because I was a little lazy when I wrote this problem and didn't want to deal with that. So let's take a look. I'm going to say that, first of all, I know that g of x is continuous. I don't know that I haven't really properly explained why g of x is continuous. It's continuous because g prime exists everywhere. We can see that because g prime is f of x and f of x exists everywhere from -1 to 5. So we're definitely continuous on that interval, but I'm not going to write it. I'm going to try to get away without writing that. Normally I would do the candidates test on this, but you can see that the derivative g prime, which is just f of x, is greater than or equal to 0 everywhere from 0 to 5. So the absolute max has to be at the right endpoint. So you don't, like I usually just immediately dive into the candidates test. I would have found critical point. I would have evaluated at 0. I'd evaluate at 5 and at 4, the critical point. I don't really need to do that. So instead I'm going to make an argument where I say that g prime, which is f of x, is greater than or equal to 0 for all x on the interval from 0 to 5. And so that means that g of x is increasing. Since g of x is increasing, the absolute maximum has to occur at the right endpoint. Now, I don't actually know of a theorem name for that, but like common sense, that has to be true. So our absolute max will be at the right endpoint, so I'm actually just going to find that. So our absolute max is definitely g of 5, which is going to be 2 plus the integral from 0 to 5, f of t dt. Now we have to figure that out. So I look up here, and I think from 0 to 2, it's kind of annoying to find. So I'm seeing this big square here, which is 3 by 3. So that would be 9. There's this other square here, which is 1 by 1. So that would be 1. And it's triangles, right? So I really want half of that square, half of the big square minus half of the small square. So I'm going to do 9 minus 1 and then divide by 2, which gives me 4. I could also just treat the region from 0 to 2 as a trapezoid, which is probably actually easier. It'd be half. The base is 2. And then, or the height, I guess, 1/2, the height is 2, and then the sum of the bases is 1 plus 3. So it's 1/2 times 2 times 4, which is 4. Either way, you're getting 4. From 2 to 4, triangle, it's half of 6, so that'll be 3. And then from 4 to 5, triangle, it's half of 3, so 1.5. So we're going to get 2 plus 8.5. which is 10.5. That's the absolute max. So don't always dive in with the candidates test, even though like I'm more guilty of that than probably anyone I know. If I see absolute max or min on a closed interval, immediately I'm like, candidates test, just doing it. Sometimes you can give a better, more succinct answer by doing something else. Let's look at the next part. We want to evaluate the integral from 0 to 3 of x squared f double prime of x. So I will warn you that I'm about to do a lot of work that I think is unnecessary, but maybe comment below if you think this is the way to go. I think it's not. I'm going to do it anyway. This looks like integration by parts, so I'm going to set up integration by parts. So I'm going to say that u is x squared, that dv is f double prime of x dx. I'm going to set up my table, which has uv in the sign. So remember, for u, it's all derivatives. So x squared, 2x, 2. For v, it's antiderivative, so first I have to find the integral, which would take me to f prime, and then take the integral of that, which is f, and then I need the integral of that, which is just, I don't know, the integral of f, right? And then our signs always starts at negative, it always goes minus, plus, whatever, for as long as it needs to. So we can find the antiderivative of this, right? It's going to be, you multiply across, so it's like x squared f prime minus 2xf plus, but of course we have to go from 0 to 3 there. So from 0 to 3, and then plus 2 times the integral of f from 0 to 3, right? And all of this is, when I wrote this problem, I thought this is amazing. This is a really clever problem. I'm very excited about it. Now I'm going to go through and find some values because we need to do that. So we need to know what's happening at 0 and 3 for f and f prime. So remember, this is the graph of f that we were shown above. So at 0, you just get 1 and 1 for both. At 3, you get, here's your point at 3, basically 3 halves. And then the slope is actually, you go down 3 and over 2, so negative 3 halves. So now we can like fill in values for things. So we can say, you know, it's going to be 3 squared is 9, then f prime is negative 3 halves, and then minus 2 times 3, and then times 3 halves. And then at 0, because you're plugging in 0 for x, you have 0 times f prime minus 2 times 0, so everything just zeroes out. So we get that. Very exciting, right? Now we need to know 2 times the integral from 0 to 3. So 0 to 3, we can go to the graph again, right? And say we need to go from, I'm going to go 0 to 2 and then also from 2 to 3. So we already found this. I'm going to do the trapezoid this time. It's 1/2, 2, and then 1 plus 3, which just gives us 4. This is also a trapezoid from 2 to 3, so it's 1/2 and then 1, and then it's 3 plus 3 halves, which if you do the math on it, I'm pretty sure it gives you 9/4. So the total from 0 to 3 is 16 plus 9 all over 4, so 25 over 4. And we get this. It's looking pretty good, right? So then this will just give us negative 27 over 2, and then minus 9, and then plus 25 over 2. So that's going to give us negative 10 overall, right? So I got that. I was excited about it. But then I'd like thought a little harder, and I was like, wait a second. I think all of that is wrong because I think really, if you think about it, this is the graph of f, which means that f prime is just like the slopes. So I'm doing kind of casual work on this, not great. The slopes are 1, basically less than 2, and then negative 3 halves, like from 2 to 4. Okay, which means that f double prime, because f prime is a constant, f double prime is just 0, like everywhere except at 2, where f double prime doesn't exist. So wouldn't that mean that x squared times f double prime is just 0? So really you're just doing the integral of 0 from 0 to 3, which would be 0. It's like if you're not moving, like what's your displacement? It's going to be 0. So I think the actual answer to this is 0, and I don't think it's a good problem. Now I think it's a confusing problem, but super good practice, I guess, on the first part, but I'm pretty confident the answer is 0. I'd love to hear your thoughts on the problem. I think it's like a good looking problem, but maybe not a good problem. Let's take a look at the next question, which is the graph of f, same setup, right? The second degree Taylor polynomial to g of x at x equals 1. All right, so we just need to know g of 1, g prime of 1, g double prime of 1. All things we can find. G of 1 is going to be 2 plus the integral from 0 to 1 of f of t dt, which I think is probably not that bad to find. It's a trapezoid that is 1/2 times 1, and then, so that's just 1/2, and then 1 plus 2, right? So this is just going to be 3 halves. And then, so that's our value there. But we're supposed to add 2. So 2 plus 3 halves, I should say, 7 halves. G prime, we need to use the second fundamental theorem to say G prime is f. So to find G prime of 1, we're just finding f of 1, which is 2. And then, so there's 2. Now G double prime is going to be f prime, and f prime is the slope of this graph, so f prime of 1 is going to be the slope at 1, which is just 1, because you're going up 1 over 1. Now we can write our polynomial, so we'll say that G is approximately the value at 1, so 7 halves, and then plus the first derivative, which is 2 over 1 factorial, x minus 1 to the first, plus the second derivative, which is 1 over 2 factorial, x minus 1 to the second. And that's the end of it, basically. A weird little thing happens here, though. It's actually the case that the second degree Taylor polynomial for this thing is this thing, right? Because if you think about it, g of x is it's 2 plus the integral from 0 to x of a linear function. If you integrate a linear function, you get a quadratic. So this actually is g of x. It's not just the polynomial. So like, I'm going to leave it as is. This question kind of got away from me when I was writing it. I don't really know. I think that's an interesting fact and still a valid, good problem to do. But we could actually say in this case it's equal to g of x. It's not approximately g of x. That actually is g of x, at least on the interval from -1 to 2. So that is, I think, interesting, but maybe not what I was originally going for. All right, one more problem. We got to evaluate the integral from 0 to infinity, 3 to the x over 1 plus 9 to the x dx. This is an improper integral. So my first thought is this is either going to be a natural log or it's going to be arctan. Like, those are kind of the two things that jump out at me for this. In this particular case, because 9 to the x is 3 squared to the x, which is the same as 3 to the x squared, I think this is definitely arctan. So I'm going to rewrite my integral as this. And we're just going to say that like u is equal to 3x, right? And then, so then du is going to be 3 to the x natural log of 3 dx. So then 1 over natural log of 3 du is 3 to the x dx. That's the process we're going to do. First, notationally, we have to rewrite this thing as the limit as b approaches infinity, 0 to b, and then just our integral again. So this, as I previously said, this is going to be arctan, so there should be a natural log of 3 in the numerator, so 1 over natural log of 3, and then arctan of 3 to the x, and we're going from 0 to b. All right, so we do the limit as b approaches infinity, 1 over the natural log of 3 is still going to be there. We get arctan of 3 to the b over the natural log of 3. And then, so there's no, the next part doesn't have b involved, so I like closed my limit, and I'm just going to plug in 0. This will be minus 1 over natural log of 3, arctan of 3 to the 0, which is 1. So we need the arctan of 1, which is famous, and you should try to remember it. This limit, the limit of arctan as you go to infinity is pi over 2. The limit of arctan as you go to negative infinity is negative pi over 2. Those are really important values. You should definitely remember them. They come up in limits a lot. So make sure you kind of have those mentally down. And then the arctan of 1 is pi over 4. It's like the next most famous thing about arctan, I guess. And then finally, we just combine these. So we get pi over 4, natural log of 3. There's other ways you can write that because of properties of natural logs. Like you can make it pi over the natural log of 3 to the 4th, which would be 81. I don't know why you would do that, but multiple choice sometimes does that. Anyway, those are the problems. I hope this was helpful, and good luck.